I'd like you to think with me how simple it is for someone to connect to our physical networks. So for this switch, if we have physical access, we could, boom, plug into it. Now, hopefully, we've got our physical switches and gear in locked up closets that are air conditioned and everything else. But it's still pretty easy for a user to connect because we have RJ45 jacks in their offices and their cubes, and all they do is they plug in. Now, the question I have for us is, what is connecting to our network? And that is why we need the feature of port security. So in this video, I'd like to talk with you about what it is and why we need it. And I see three major challenges with controlling who's connecting to a port. Number one, we just don't know who exactly it is. I mean, maybe it's Bob today or Sally tomorrow, or maybe Bob comes in with another device that's not his PC and he plugs into the jack in his office and we've got this thing connected to our network. So who or what is connected is a problem if we're not sure what it is or we can't control it. Another challenge is that we could have multiple devices connecting on one port that are not authorized. And here's an example. Bob decides he's going to bring in some more devices to work and he wants them in his office. So he disconnects his PC from the network connection and instead he puts in his own switch, which are very affordable for a non-managed simple switch. So he bought it at Fry's or some other store. He brings in, he connects his network connection to the switch, and then from his switch he connects his PC and all of his other toys that he's brought in that he wants physical access to the network with. So we could have multiple devices all coming in on this one port, and that port is gig 0/0 on the switch. And the third challenge is that there could be a hacker or somebody malicious who is connecting to a switch port and trying to compromise the switch. And one technique that can be used is called a CAM table overflow attack, also sometimes referred to as MAC flooding. And here's how it works. Using malicious software or software intended to harm the switch, the device connected to the switch sends in thousands and thousands of frames, but instead of using its real MAC address as the source address, it'll create a bogus MAC address or a made-up MAC address for every single one of the frames. So now the switch is learning thousands of source MAC addresses all off gig 0/0. Now, what's the real harm in that? The real harm is that the switch does not have unlimited memory to remember all that information. It uses the CAM table, the content addressable memory space, to remember MAC addresses. And if that is totally consumed, the switch is not going to have the ability to correctly understand which MAC addresses belong to which ports. And so the hacker, if they do this CAM table overflow attack and then eavesdrop on the network, their intent is that they want to see every frame from every device on that VLAN being sent out their specific port where they can now listen to all the traffic on the VLAN. It's also possible that the performance on the switch is going to be compromised, which could also act as a denial of service attack against the switch. And just for fun, let me demonstrate how easy it is to do that type of an attack, a CAM table overflow attack against the switch. So here at the access layer switch, let's do a few commands just to verify that gig 0/0 really is associated with VLAN 10. So we'll do a show VLAN brief. That'll do it for us. And there's VLAN 10, and VLAN 10 currently has gig 0/0 assigned to it. Fantastic. Also, if we want to take a look at the MAC address table, we can do a show MAC address table, and then we can filter it down even further by specifying VLAN 10, press enter, and there's all the MAC addresses it's learned, the switch has learned, they're associated with VLAN 10, and we can even do one step further. We can go ahead and do a show MAC address dash table space and interface gig 0/0 space VLAN 10. And that will narrow it down to the VLAN 10 MAC addresses that it's learned that are associated with that specific interface. So at the moment, there's just 2 of them. Now, I have another host that is connected off of gig 0/0, and it happens to be a Kali Linux box. So if I log on as the user root with the password toor, T-O-O-R, which is root backwards, and then in Kali Linux, we'll open up a terminal. And from here, if we do an ifconfig, just to verify our information. So our IP address is 10.16.0.99. And our MAC address is ending in FE 4 7s and a 0 and a 1. So that also should show up as a dynamically learned layer 2 address on VLAN 10. Let's go take a look. So back at the CLI, we'll do an up arrow key, press enter. It's not there. Well, let's go tell the Kali Linux box to generate some traffic. So back at Kali, let's generate some traffic. We'll do a ping to 10.16.0.1. That's the VLAN 10 interface on Core 1. We should get a response there. Great. I'll do a control C to stop that ping. Let's go back to the CLI. I just want to verify that we are on the right port. And we'll do a show MAC address table for interface gig 00 VLAN 10. Press enter. And sure enough, there it is. So the Kali Linux box was being very quiet in the background until it generated some traffic. So with this command right here, we have 3 MAC addresses that this switch has learned off gig 00 that are all associated with VLAN 10. However, if we use a little utility like MacOF, which is built in as part of the toolset on Kali Linux, we could use MACOF space, and then we could go ahead and do a -I, specifying, hey, on which interface do we want to use? And we want to use Ethernet 0 space. And then, just to be kind, I'm not going to just let this run and go, millions and millions of packets. I'm going to go ahead and do a -N, and I'm just going to do like 50. Now, this is going to spit out 50 frames, all of which are going to have a made-up source MAC address as we start to fill up the CAM table. It happens really fast, and in this virtualized environment, this Kali Linux box is pumping them out faster than the actual switch can actually learn them, because it's also virtualized. So I'll do that a few times. And then let's go take a look at the CAM table. So a moment ago, we had 3 MAC addresses that were associated with VLAN 10 on port gig 00. If we hit the up arrow key now and do that same exact command again, here we go. There's page 1, there's page 2, there's page 3, etc. And if we want to do a show MAC address table, and we'll do a count for VLAN 10 and press enter, that's going to give us a summary. So we have 113 MAC addresses, and that's because I only did that command a few times. But a real attacker would just let it run and try to compromise the switch by doing a CAM table overflow attack. So now the question is, how do we protect ourselves against those 3 things? Number 1, not knowing exactly which device is connecting. Number 2, having multiple devices connecting on a single port. And 3, having somebody try to do a CAM table overflow attack against us on the switch. And the answer is a feature called port security. And in the next video, we'll take a look at how this feature called port security protects us against those scenarios. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.